Okay, so welcome to this set of videos. This is around volume. So you can get onto the Teams, and on Teams you will find in your maths tile, if you have a look around, you'll find this particular booklet, volume unit 2021, grade 10. And on there are a couple of things that I want you to go away and research for me and find out. So what is volume? What's it measured in? And some basic facts that are there. I am going to show you the front bit. So if you have a look, the front page, here are some examples. Mine are slightly different than the ones in the book, but hopefully now you can fill them in. I'll also fill these in as well and show you the answers later on. And then there's some paired examples that you can work through, as well as some questions that are here. Question 3 in the booklet, in this particular section, you may actually have to use some Pythagoras to find this height of this, or you can just skip question 3 and go and have a look at question 4. So, as we have a look, we've got two shapes here that we're going to start off with. And you notice also I've got a calculator here. It's going to be outside of shot, of course, because I've only got so much room. So, the other things you need, the volume booklet, calculator, and of course, purple texter. And keeping going, purple texter, you don't need it. So what is volume? Well, basically, I always think of volume, if I look at this particular shape, as finding the area of this particular flat bit, so the face of my particular shape, and then just applying many different layers as I go across. A little bit like sheets of ice stacked upon each other. So if I look at the front shape, so the volume is going to be equal to length times width, because that's the area of this. So length times width, and I'll put an L there and a W there. But then we've got this added dimension, which I'm going to call depth in this particular case. So it's length times width, and then of course we times by the depth. So finding the area of this, and then as I said, just stacking those sheets of different rectangles back, and back. That's the way I look at volume. So if we have a look here, we've got a formula, and we've got these measurements. So I know that my length is, of course, 8, and my width, 14, and my depth times 10. Now, some other people may have their length down here and their width there. It doesn't really matter, because as we notice, 8 times 14 times 10, of course, is exactly the same as if I just written this as 10 times 8 times 14. It doesn't matter in which order I actually multiply these numbers together. So putting them into the calculator, 10 times 8 times 14 gives me the answer of 1020. Now we need to consider the units. Now, if I think of the units of area, that's in centimetres squared, but I've added this extra or third dimension. So I'm actually going to make my units centimetres cubed. So if you have a look, we just identified the different things. We worked with our formula. We put our numbers in. We realised that it didn't matter in which particular order we put these numbers together, because as we multiply them one way or the other, we're still going to get the same answer that we got here, and we had to be super careful of the units in which we put on. So if we have a look at this one down here, we've got 6, 14, and 11. So that's your paired problem. Now I'll pause the actual video and see if you can do this. And I'll give you just a couple of seconds to do that. Okay, so hopefully you pause that, and hopefully you have an answer for our paired problem that's here. So I'm just going to fill it in. So volume is equal to length times width times depth. So as we know, it doesn't really matter which order we put these numbers in. So 14 times 6 times 11. And of course, quickly putting them into the calculator, 14 times 6 times 11 gives me the answer of 924. Now, as we've been speaking in class, I'm just going to go back and I'm just going to do that again, because I don't want my answer to be wrong because of a calculator error. Yep, 924, checked it. It's going to underline my answer that's there. So if we go to the booklet now and we have a look at the example that's in the booklet. Hang on, let's get that out. We can now fill this in. So looking at this, we know that our volume is going to be equal to our length times our width times by our depth. Now sometimes I do my L's a little bit strange. So L, D and W. And of course filling this in, we're going to get 6 times 2 times 4. So 6 2s are 12, 12 4s, 48. Now what I'm actually going to do, 6 times 2 times 4, is once I've worked that out, once again, I'm going to put it into calculator, centimetres cubed, because while I know it's 48, always good to check. So there's our first example in our booklet, and if you flip over and have a look at the paired problem, just here, I'm going to give you a couple of seconds to do that. You can pause the video, and I'll get back to you. Okay, so we're back. And you may have noticed that this question is a little bit strange because, of course, it's not so much a rectangular prism, but it's a cube. And what do we do in this case? Well, it doesn't matter. It is still going to be, the volume is length times width times depth. Now, if you go looking on the internet, you might actually find that it's the volume is the length cubed. And that's, of course, because when we go 4 times 4 times 4, if we think back to our indices, that's the same as 4 cubed, which, of course, is 16 times 4 is 64. So 4, and I've got a cubed button on my calculator. Once again, just checking, 64, and, of course, what were my units? Centimetres cubed. So either way will actually give you exactly the same answer. So you can treat a cube as just a special type of rectangular prism if you want. Okay, so we've looked at rectangular prisms, but we've still got another one to go. We're going to look at a different type of prism. Now I noticed when we did surface area before that many kids miss the fact that the formula for the area of a triangle, so this space that's in the front here, is half the base times the height. Now, many of you are missing the half off, and that, of course, means you can't get it right. If we look at a rectangle or a square, there's probably more of a rectangle than a square, and I draw a line from one side to the other, we can see that I make two triangles which are exactly half of each other. So this is where the half part comes within that particular formula. And, of course, if this is area, if we want the volume of this shape, well, all we've got to do is find the area, once again, and then times it by how deep our shape is. So if we have a look, this would be our base, this would be our height, and of course this would be our depth in this particular question. So let's put in what we know. V is equal to a half, must not forget that, times my base, which is 12, times my height, which is 6, times the depth, which is 10. Now, when I apply this half, doesn't really matter. I can apply it after I times these numbers together and then half them. I can half the 12, I can half the 6, I can half the 10. I'm actually going to half the 12 in this particular case. It's going to give me 6 times 6 times 10. Now I know that 6 times 6 is 36, times 10 is 360. But once again, I will also do it on my calculator just to make sure that I haven't got one of my number facts wrong. It's always good to be going back over what you've done or checking your particular working out. So once again, what were the things that we needed to remember about this? Well, we needed to remember this half. Lots of us forgot it in surface area and we just went base times height, and that's why we got those questions wrong. So in this particular case, we need to make sure that we are using the correct formula for the correct shape. And I told you in class that you could make a formula sheet of your own. Otherwise, we'll just be giving you this particular formula without a picture. And remember, if you're making a formula sheet, a picture can be incredibly handy. So your paired problem is underneath, and then of course we're going to finish off by doing one of the examples that's on the sheet. So, pardon me, I'm just going to pause for a minute. You can pause the video and attempt this question just down here. Okay, so we have a look at this particular question. Once again, the thing to remember is the half. Don't forget it. Okay? Times the base, times the height, times the depth. So I'm going to go half times 10 times 8 times 12. So half of 10, 5. 5 times 8. Oh, sorry, that should be a times by 12. So 5 8's are 40. 40 times 12. Well, let's do that. 40 times 12, 480. Okay, I need to put the 0 there. And we need centimetres cubed. Okay, I'm just going to do that one more time on my calculator. 5 times 8 times 12 gives me 480. I would hate to put 460 there, and just because I've read the calculator wrong. I had one kid today, had 526, and they just randomly wrote 226. So just make sure you're checking. Take your time, guys. Take your time. Anyway, we're up to 10 minutes, so let's get moving a little bit quicker. And let's have a look at this particular one that's actually in the example that's in your booklet. So once again, volume is half times my base times the height times how deep it is. So B, H, and D. So volume is equal to a half times 10 times 3 times 12. So half times 10 is 5 times 3 times 12. Let's calculate back in. 5 times 3 times 12 gives 180 centimetres cubed. Now, once again, 5, let's put the right number in. 5 times 3 times 12, 180. So I checked my answer, so I'm sure that I'm right. Okay, and of course, the last one sitting here is yours. Okay, so hopefully there'll be a copy of the booklet with the solutions in there towards the end of the unit, so you can check it then. But if you want to have a quick look, it's going to be a half times 4 times 7 times 12. I'll give you a bit of a chance to look at where I found those particular values from. And then putting that in the calculator, we get 168 centimetres cubed. So don't forget to work your way through these particular questions that are here. That's your particular task. The next video I'm going to make is going to look at cylinders, and then we're going to be moving on to Vault 1.B, where we're going to be looking at cones, spheres, and pyramids. Thank you for watching. Hope everything's going on well for you out there, and I'll see you later.